In this video we're going to see how we can find equivalent fractions. We're going to have a look at a few examples. There are some very important vocabulary that you already know, the numerator, the denominator. Equivalent and equal are very important words that we're going to be using. And then the word multiples, which you will see in a second as well. Then there are two very important ideas that we repeat ourselves that you've heard in different videos as well. One is the fact that you have to do whatever you do to the top, we do to the bottom. Whatever you do to the numerator, you do to the denominator. And the other one is that different fractions will have the same value, although we have different appearance. Let's have a look at them. We've got the first one, which is 1/3. So as you can see here, I'm going to give you three different fractions that are equal to 1/3. How can we do that? Well, I can multiply the numerator by 2, and remember, whatever we do to the top, we do to the bottom. So if I multiply the numerator by 1, I multiply the denominator by 2 as well. There we go. So 1 multiplied by 2 is 2, 3 multiplied by 2 is 6. Now, those fractions which are equivalent, it means they basically have exactly the same value, although they look very differently. So I'm using multiples of both in order to get this equivalent fraction. So 6 is a multiple of 3, and 2 is a multiple of 1. Let's have a look at how from 2, 6 I can get into another fraction. I'm going to multiply by 3. Whatever I do to the top, I do to the bottom. So I do the same to the denominator. 2 multiplied by 3 is 6. 6 multiplied by 3 is 18. You can see that the 6 is a multiple of 2, 18 is a multiple of 6, but most importantly, we've got two fractions with different appearance, exactly the same value, and we do exactly the same to the top and to the bottom. And we could do it once again, and instead of multiplying, we could even divide. I could divide this fraction by 2, and whatever I do to the top, I do to the bottom. So I could divide the denominator by 2 as well. So 6 divided by 2 is 3, 18 divided by 2 is 9. You can see here that absolutely every single fraction is completely different. They have a very different appearance. The value is the same because I'm multiplying or dividing the numerator and the denominator by the same number, by 2, or by 3, or multiplying by 2. These other examples, we've got slightly different activity because we've got a fraction which is 3/6. We know this fraction is equivalent, but we do not know the numerator. All we know is the denominator. Now I can see that from 6 to 12, if I think that 12 is a multiple of 6, I have to multiply it by 2. 6 multiplied by 2 is 12. And therefore, according to what we said earlier, I have to do exactly the same to the numerator. So if I multiply by 2 to the denominator, I do the same to the numerator. So 3 multiplied by 2 is 6. 3, 6 and 6, 12. Once again, they're equivalent. And as we show you in the first example, sometimes you multiply, but sometimes you divide as well. Because have a look, we've got the other way around. We've got 10 12s. I know that there's an equivalent fraction with the denominator 6. Now I cannot multiply 12 by a number to give me 6, but I can divide 12 by a number to give me 6. If I divide 12 divided by 2, give me 6. So I'm going to do exactly the same to the numerator. I'm going to divide it by 2. 10 divided by 2, it's 5. 10, 12, and 5, 6, equivalent fraction with the same value, but a very different appearance. In this video, we're seeing how we can find equivalent fractions with a different denominator, completely different, but absolutely the same value.